Okay, I got new graphics this time. Okay. Engineering 305, Chapter 2, Problem 49. The stresses shown in the pictures below are part of a thin wall pressure vessel that's got internal pressure, an axial load, and a torque. All of that adds up to give us the stress situation shown on the stress square there. And the question is simply find the normal and shear stresses at this point where this is taking place on the inclined plane. So I'm going to leave that up, but I'm drawing right behind here. I'm drawing, there's that square, and it's got a 6 KSI in the Y direction in tension. Excuse me. Oh, it's got, excuse me for that, it's got 18 KSI in tension in the Y, in the X direction, and it's got a positive shear stress of 15 KSI. All right, it's going to look just like that. All right, that's my little square. But then I got to put on that, they want us to have this line where that angle is 65 degrees. Looks like that. All right. What direction is my normal? My normal is this direction. And while this angle is up 65 degrees, that means that this is going to be down 25 degrees. My coordinate system X is this way, Y is that way. And there's my normal. There's my normal. There's my shear. And this angle is 25 degrees. Getting that correct is a huge deal. Getting that correct is a huge deal. All right? I guess I'm going to do one more thing on this problem since we're repeating this. There is another way to draw that, and that is we put this dotted line in here, and I can say that could also be n. I'm going to call it little n. All right? And then this angle, remember this is 65 degrees, and that's 90. So that whole angle all the way around is 155 degrees. And either one of those angles would work. They're going to give you, you'll see where if you recall from the lecture, I work with cosine squared. Well, it doesn't matter what the sine is. Sine squared, doesn't matter what the sine is. And in this quadrant, cosine is positive, sine is negative. In this quadrant, sine is positive, cosine is negative. And so either way, I'm going to get a negative when I look at that term on the shear stress. So it doesn't make a difference. Either 25 or 155, you'll get the same answers. Now, I'm going to go back one more time. I'm going to go back. I'm going to list my sigma x is a plus 18 KSI. I'm going to add sigma y is equal to a 6 KSI, also positive. My shear equals 15 KSI, also positive. And then my angle, 15 or 155 degrees. Either one. Sorry, that's not right. 25. 25 or 155. And now we're going to punch into those equations, which I hope they're starting to get kind of old. I'm going to write it down. Sigma n is equal to sigma x cosine squared theta plus sigma y sine squared theta plus 2 tau xy sine theta cosine theta. So I'm gonna turn it off so you can look at mine. Again, cosine term is squared, so it doesn't matter. They're both going to give me a positive value. Sine squared, both going to give me a positive value, and one of each. So as long as I stay in the fourth quadrant or the second quadrant, the product of the two is going to be negative. Okay. I can go ahead and calculate that. I can start substituting in, right? And sigma x is 18. Wow, that's, I got to go back and look. Yeah, 16. So it's 18 cosine squared. I'm going with the 25 degrees just because it's less buttons to push in on my calculator. Plus sigma y, oh, I got to put this in. It's 6 sine squared of 25 plus 2 times 15. 15 is the shear stress times sine 25 cosine 25. And that's going to be equal to 4.37 KSI in tension. So that's positive, and I'll just put that in brackets. And I'm just going to repeat the process. Shear is, well, it's not exactly the same process. Remember, that equation's different. I've got the shear equation, which, yeah, I still don't know which one I like better. But we're going to go with 213A, which is negative sigma x minus sigma y times sine theta cosine theta plus shear xy times cosine squared theta minus sine squared theta. And then and then I can substitute into that, and when I substitute in, I'm going to get that my shear is equal to 14.4 KSI. All right? There's one more done. Do the numbers make sense? Do I have something to compare it to? Well, 14.4 KSI is in the realm of what those numbers are. These numbers are, this is between 15 and 18, and so I'm going a little bit, I'm going from here to here. Well, it's going to go down, because if I go from here all the way to here, it goes down to 6. So I should be working my way towards 6 as I go. So, yeah, it makes sense. It makes sense. I guess, when I do this, that's a Mohr circle concept. So if you haven't done the Mohr circle stuff yet, maybe you don't recognize that, but that's okay. If you go back and visit this later, it'll make good sense. Hope you're doing well.